welcome back once again. If you are just joining us for the first time, I want you to know that I've solved question 1 to question number 8, and they are all on my social media handle. Okay, just look at the name there, Matt tells you can get the solution to those questions on Facebook, TikTok, YouTube. Please, when you get there, don't forget to subscribe on YouTube. Don't forget to follow on TikTok, okay? And the same thing on Facebook. Also, I plead with you, like the video, share the video, all right? Now, question number 9. Question number 9 goes like this. A liquid of mass 2 kg at 61 degrees Celsius is kept in a large vessel. If another 2 kg of the same liquid at 21 degrees Celsius is added to the liquid in the vessel, calculate the final temperature of the mixture. Okay, now from the question, you would notice that one liquid was added into another liquid. Now, the principle that plays in there, according to the movement of heat, is that heat moves from a higher temperature to a lower temperature. All right. Now, from the question, we have a liquid of mass 2 kg. So I'm going to have M1 is equal to 2 kilogram at theta 1 equal to 61 degree Celsius. Okay, now I have the second liquid, which is M2, is of the same mass, which is 2 kg. At what temperature now, which is my theta 2, is equal to 21 degree Celsius. Okay, now it's added to liquid in the vessel. Now we are asked to calculate the final temperature. We can say let the final temperature be theta 3. Let's use theta 3 to represent our final temperature. Okay, now according to the quantity of heat, which is heat is equal to what? Mass times the specific heat capacity of the substance times change in temperature. Okay, times change in temperature. Like I said earlier on, that this is under the method of mixture. Now, from the question, like I said, you would notice that the first liquid M1 is at 61 degrees Celsius. The second liquid is at 21 degrees Celsius, right? Liquid M1 was added into the liquid M2. So what happened here is that the liquid M1 lost heat, right? The liquid M2 gained heat. Now, according to the principle of conservation of energy in the context of heat change, is equal to heat loss by the liquid at higher temperature is equal to heat gain by the liquid at lower temperature, because that is the movement of heat, right, from a higher temperature to a lower temperature. Now, what we are going to have is our heat loss, right, by the liquid at higher temperature, which is this one at higher temperature, okay, equal to heat gain now. Heat gain by the liquid at lower temperature, and the liquid at lower temperature is temperature 21 degree Celsius, right? So according to this principle, quantity of heat now, I'm going to have my heat loss. I'll express my heat loss as what? M1 times the specific heat capacity times change in temperature, is a symbol, times change in temperature equal to the heat gain now, which is equal to what? M2 heat gain times the specific heat capacity times change in temperature as well, okay? Now, since the liquid is of the same type, what that simply means is that they have the specific heat capacity. That is, this is going to cancel this other C, right? Because they are of the same type, okay? Now, my temperature change, I will express my temperature change as M1 times open bracket for my heat loss now is going to be the temperature, the initial temperature minus the final temperature of the mixture, which is theta 3, okay, equal to my heat gain now is going to be M2 times the change in temperature now is going to be the final temperature of the mixture, theta 3 minus theta 2, all right, plus my bracket in that order. So remember, it is theta 3 we are looking for, which is the final temperature of the mixture. So what I'm going to have here, I will substitute my value. My M1 is 2 times my theta 1 is 61 degree time, okay, sorry, minus theta 3, close my bracket, equal to my M2, 2 times theta 3 minus my theta 2 is what? 21, okay, close my bracket. So by opening the bracket, I'm going to multiply 2 by 61 and by theta 3. The same thing on this side as well, okay? So 2 times 61, I'm going to have 1, 2, 2, right? Minus 2 times theta 3, I'm going to have 2 theta 3, okay? Equal to the next thing, 2 times theta 3, I'm going to have 2 theta 3 minus 2 times 21, that will give me 42, okay? So the next thing is collection of like terms. So I'm going to have 1, 2, 2, and I'll carry minus 42 to this side, okay, which will give me plus 42, which will give me plus 42 equal to 2 theta 3. I'll carry minus this to this side. I'm going to have plus 2 theta 3, okay? So if I add 122 plus 42, I'm going to have 162 equal to 4 theta 3. The next thing is I'm going to divide both sides by 4. I will divide both sides by the coefficient of theta 3. Okay, so I'm going to have divide by 4, divide by 4. 4 will cancel 4. So my theta 3, which I'm going to have 162 divide by 4. Okay, so my theta 3 is 41. Yes, if you press your calculator, you see it's 41 degrees Celsius. Okay, now this is the final temperature of the mixture. All right, and if you check the option from the question, you will notice that B is our answer. Okay, please, if you find this interested to you, don't forget to like the video, share the video, and also subscribe to the YouTube channel. Follow the TikTok page. Okay, the next question is question number 10. All right, thank you.